Good day, everyone. Once again, we're kind of moving along with the lessons going into 3-1. Today, our goal is to talk about an arithmetic or geometric sequences based off the recursive form, and then to actually determine the explicit form of a recursive sequence, okay? So far, we've kind of been talking about explicit statements. Basically, how do we find something within a pattern? Okay, how do we find a specific number within a pattern? How do we find the sum of that pattern? Things like that, okay? Well, today we're going to talk about the other idea, okay? So we have this thing called a recursive statement. Now, recursive statement basically means that you need to use the previous term to actually find your next one. Now, rarely do you actually see this in math where you actually need to use it. A lot of times your pattern, you have a consistent difference or consistent ratio in which you can basically jump to a specific value. In some cases, and you'll kind of see that today, we can't really do that. Even though we have a pattern in front of us, we cannot use the explicit statement, so we need to use a recursive statement. So with that being said, let's go ahead and jump into it. So basically, we have this specific problem here, okay? And to really understand this lesson, we're really going to need to understand this problem in general, okay? So let's kind of go through a couple of things. Maurice and Lester are twins who have just graduated from college. They have been offered jobs where their take-home pay would be $2,500 per month. Their parents would have given Maurice and Lester two options for a graduation gift, okay? Option one, if they choose to pursue a graduate degree, their parents will give them each a gift of $35,000. However, they must pay for their tuition, living expenses out of the gift. Okay. So let's go ahead and just underline a couple of things. $35,000, but they have to pay tuition and living expenses. The next problem, option two, if they choose to go directly into the workforce, their parents will give them a gift of $5,000. Okay, so if they go to work, they get a $5,000 gift. If they go to college, they get $35,000, but they're paying for everything. This is where we have to kind of really start looking into things. Maurice decides to go to college for 2 years, to go to graduate school for 2 years. He locks in tuition rate by paying $11,500 for 2 years. He figures that his monthly expense will be $1,000. So he has a $1,000 monthly expense with $11,500 every 2 years, and he paid $11,500 straight up with $1,000 expense each month. Lester decides to go straight into the workforce. Lester finds out after paying for his rent, utilities, and other living expenses to be able to save $200 per month. Okay, so Lester's going to be saving $200 per month, while Maurice has to pay to get his graduate degree. Okay, the parents deposit the appropriate amount of money in the money market account for each of the twins. The money market accounts are currently paying nominal interest rate of 3%, 3% compounded monthly. Okay. Before doing any calculations, predict which twin will have the greater balance in money market account after 2 years. Will that twin always have more money in the account? Okay. Well, I mean, this question here, number one, is fairly easy, right? Because if you think about it, Maurice is spending money over the 2 years. Even though he's given a $35,000 upfront payment, he's going to be losing money over time. While Lester, given the fact that he's only given $5,000, he's still going to be making money. So while one of them is going to lose the money over 2 years, one of them is going to be gaining it. So the idea here is Lester should have the more money because he is actually depositing the money versus withdrawing it, okay? Next, for number two here, after Marcus withdraws $11,500 for tuition, how much money is left in his money market account? So he needs to pay $11,500 for tuition, right? He pays that straight up out of the $35,000. So to simply solve this, we want to know how much money does he have after this. We take the $35,000, subtract it from the $11,500. to get a value of $23,500 left over, okay? Well, now to continue this problem, what we really need to understand is this idea here. And this is something that kind of goes back in algebra when we used to talk about how to actually solve a compounding interest rate formula, okay? We want to know basically how much money is he going to gain or lose each month. But within a money market account, it's going to actually grow. That value of that money that's in there is going to continuously go up. However, we have to understand that his value or his money is going to be decreasing as he goes along. So what we're going to do is use this equation here, all right? To go over a couple things, your principal, the p-value, is your starting value. So that's going to be our $23,500. The ratio, the R is the interest rate, which we know was 3%. So we have a 0.03% interest rate, a principal of $23,500. They said it was compounded monthly if you look back, so this is going to be a 12. And then because we really are looking over time, this doesn't matter to us right now. Now, in other equations, yes, you'll need to actually plug this in to where you actually know, like after 5 years, after 6 years. In this particular problem, we're going to go monthly because we need to know how much each month he has. Okay? So let's go ahead and kind of look at this. After we plug that all in, the equation is shown in number 3, where we have our principal times 1 plus 0.03 divided by 12 minus $1,000. Okay. Now, the reason why I have to add this minus 1,000 in here, even though it's not in this problem here, is because even though we are gaining money, even though that this value is our increase, we're still losing that $1,000 each month. So basically what's circled in purple is how much we're gaining in the money market account, while this minus 1,000 is how much we're losing because we have to make payments. Okay? So let's kind of talk about why this really becomes a statement, or why can't I just do this pretty straightforward? Why can't I just plug this in the calculator and get like any month of the year? Well, this is kind of what happens here. If we look at number 4, our starting value was 23,500. So if I work it out for the first time, I actually get 22,558. Even though in this initial value here, I increased, the minus 1,000, I'm actually going to lose value on it, right? Because even though I have a percentage increase on my money market account, what's underlined in black there, I'm still losing money because I have to pay for room and board every month. So what we want to do is try to figure out after each month, how much do we have? Well, if I go down the list here, that would be my first equation. If I want to make a second equation, I can't use the original value up here again, okay? I have to think, if I want to figure out how much money I have in month 2, which I have sitting over here to the right, I got to think, how am I going to create another equation? Well, the only thing that really changes in this problem is your initial principal value. How much money did you start with? Well, even though I started with 23,500 in month 0 and got to this value here as an answer, well, now in month 1, this is my value. And so if I want to figure out how much money I have for the next month, I need to use that as my new principal. 22,558.75. 1 minus 0.03 over 12 minus 1,000. And if we do that, we end up getting 21,615. Well, then same thing is going to continue, or this pattern is going to continue on, where if I want to figure out how to actually come up with the next month's value, I can't use the original or month 2. I need to use with the money I have right now. So now my next equation is going to be the same process. I'm going to do 21,615.15 times 1 minus 0.03 over 12 minus 1,000. Okay? And you kind of know this has a similar pattern that goes through it, right? We take the previous principal and plug that in for the new value. Okay? Well, here's kind of the curious thing about it. I hope right now you kind of can see that there is a little bit of a pattern here, right? We kind of can clearly see that in this equation, this value never changes. The 1 minus 0.03 over 12 minus 1,000, right? However, here's where we really run into a problem. This is why we have to use a recursive statement. To solve these out, I cannot find the next value unless I know what the previous principal was, right? If I just started with 23,500, the only answer I could get would be the next month. I could only get this value as a specific answer, right? It's not like in our other patterns where if I knew the first term and I had the difference, I could solve any value in that pattern. In this one, we can't do that. I need to have the previous value to actually solve this out. So what we can do is create a recursive statement. Now, they use like U of 0 and things like that. This is the same thing as like saying A of N or A of 0, okay? U and A are kind of intertwined within this section. So they basically want to say, how can you come up with an equation for A of N using this terminology, A of N minus 1? Now, the thing I want you to think about is A of N minus 1 is just another way to say previous term, right? If you really think about it, if you think about this value, and I'll just kind of do this off to the side real quick. If A of n, or excuse me, let's say we have an A of 7, right? If I think about this value here, A of n minus 1, A of 7 minus 1 would just be A of 6. Okay, so you see how that terminology, all it's really saying is we're going to go back a term in our pattern. So what this question here is asking for is we want to be able to create an expression using that terminology. How can we use the previous term to figure this out? Well, all it really comes down to is simplifying this equation up here. If you really think about it, we took the term in front of us, which is the principal, times the interest rate minus 100. So if I really want to try to come up with an equation, I need to solve it out like this. A of n is going to be the interest rate, 0.0025, which is just this value here simplified. If I actually plug just that parenthesis in the calculator, it would give me that value. I'm going to multiply that by A of n minus 1, so the previous term. And then at the very end of this, I'm just going to subtract 100. And what I have here is a recursive statement that can help me solve any of these values. Now, the key thing to understand when I actually built this recursive statement is how am I actually using it? All right, we have our interest rate sitting right here. So this is our rate. We have the previous balance here. And then last but not least, we have the minus 1,000, which is our cost each month, right? Well, if you really think about what I did here, I pretty much rewrote this equation as a recursive statement, right? This is our rate. This is our previous balance. And this over here is our cost. The only difference now is I'm stating it as a recursive form. This here is in our interest rate formula. Well, our interest rate formula really doesn't work when I don't have to change the principal each and every time, right? Well, what I'm doing down here is I'm creating a statement in which I don't have to do that. I don't have to change my principal. All I'm saying is if I want to find the next term, I need to know the previous term to do so. Okay? And this is what we call a recursive statement, all right? How I always remember a recursive statement is it's always going to be using the previous term to help you solve it. You always need to actually pull ahead the previous term. It's not like our other patterns where I could start at the first term and find any value in that pattern. I always need to basically count and go through the pattern to solve it, okay? Well, that's kind of the whole idea of this lesson. We'll talk about more about this in class. Besides that, have a great day.